APIs are all about providing information to the consumer. Providing highly performant and reliable APIs is a key aspect for a successful API provider. There are many APIs that provide same static data or data that does not change over a period of time. For such scenarios, caching is the best mechanism to provide a response faster to help with the server load and increase throughput. This is exactly why Roy Fielding included cache in his REST architectural style. In the next few minutes, we're going to talk about how Apigee Edge provides caching for runtime persistence of data across requests. Now, why should one use caching? Improve performance by reducing network latency and also eliminate the redundant request response processing. Reduce the amount of load to the backend services, which makes it highly stable. Makes it highly scalable to support higher transactions per second without additional hardware. Can be used to persist session data for reuse across HTTP transactions, and secured by allowing scope access to cache entries so they can be accessed only in a particular environment or by a specific API proxy. Caches are built on a two-level system, made up of an in-memory level and a persistent level. Level 1 is an in-memory cache for faster access. Each message processing node has its own in-memory cache for the fastest response to requests. On each node, a certain percentage of memory is reserved for use by the cache. As the memory limit is reached, Apigee Edge removes cache entries from the memory. Entries are removed in the order of time since last accessed, with the oldest entries removed first. Level 2 is a persistent cache beneath the in-memory cache. All message processing nodes share a cache data store in Cassandra for persisting cache entries. Cache entries persist here even after they are removed from the L1 cache, such as when in-memory limits are reached. Because the persistent cache is shared across message processors and even across regions, cache entries are available regardless of which node receives a request for the cache data. There is no limit on the number of cache entries. The entries are expired in the persistent cache only on the basis of expiration settings. As Apigee Edge typically has more than one message processor taking the traffic, the distributed caching feature allows any message processor to have access to the same cache persisted across any application restarts. An example solution needing a distributed cache is providing server-side storage for web sessions. When a cache entry's value is updated or invalidated, the message processor handling the event will notify the other message processor that the value has changed. These message processors will then remove their in-memory value for the given cache key. When the other message processors have to look up the cache value again, it can be fetched from Cassandra. The response cache policy caches the entire HTTP response, including the headers, payload from a backend resource. Hence, it reduces the number of requests to the backend resource. As apps make requests to the same URI, you can use this policy to return cached responses instead of forwarding those requests to the backend server. The response cache policy can improve your API's performance through reduced latency and network traffic. It also can be configured to set different time to live for each entry. The policy has the option of honoring the HTTP cache headers like expires, cache control for dynamic TTL. The other important support is caching of multiple formats based on the request accept header. The same policy is attached to the request and response segments within the flow. When request segment policy is reached, cache lookup happens. If cache hit is true, response is retrieved from the cache and is sent to the client. If cache misses, request processing continues, and when response segment policy is reached, cache population happens and response message is stored before sending the response to the client. Apigee Edge provides caching for runtime persistence of data across requests. You can access the cache with policies such as populate cache and lookup cache. Apigee Edge organization includes access to a shared cache that is useful for most cases. You can also configure your own cache if you want finer control of performance. Using policies for general purpose caching, you can persist any objects your proxy requires across multiple request and response sessions. For example, you may temporarily want to store session IDs for session management, credentials for outbound calls such as tokens and API keys, response content that must be paginated for your apps. With this, you get full control over what to cache and where to store these objects. Persisting and retrieving the cache data are performed by separate policies. In this diagram, for different scenarios of in-memory and in Cassandra, we see how the response is retrieved from the cache. For the scenario where the data is available in the in-memory cache, the response is sent to the client immediately. For the scenario where the data is not available in memory but available in Cassandra, the data is retrieved from Cassandra and on the way back populates in-memory cache and then is sent to the client. For the scenario where the data is neither in memory nor in Cassandra, the data is returned from the backend system and on the way back populates both Cassandra and in memory before sending it to the client. The response cache policy consists of the following key elements: cache resource, which is the cache name, and the cache key, which is created using multiple key fragments. The scope elements affects the cache key. Expiry settings, where one can specify a time of a day or date the cache entry expires, or set TTL using the use response cache headers based on HTTP cache response headers. The policy also includes an optional condition for skipping cache lookup or cache population. Now that we've covered the different policies, let's take a minute to discuss which policy to choose during which circumstances. Use response cache when identical requests and their corresponding identical responses are common and where cache hits will be frequent. To reduce unnecessary traffic to your backend and to reduce latency for common requests. Use populate cache or lookup cache when storing custom data objects or when you want to persist data across multiple API transactions. The use of caching is only beneficial if requests are being served from the cache. There are key things to ensure your cache solution is obtaining optimal performance. Use only when needed. Ensure your cache key is built in such a way that the only request parameters used for the key are the ones that dictate the client's response. For example, don't just use the URI as things like timestamps and other unique items that can end up as part of the key, resulting in a zero cache hits. Take advantage of the cache scope. Multiple APIs might utilize the same cache, so set the scope to be organization and reuse. Cache Performance Dashboard is available in the Apigee Analytics to report on the cache hit and performance gains. To clear and invalidate the cache, the following ways are: by using the UI, one can clear the entries for a complete cache resource and is typically used to invalidate all cache entries. By using the Management API, which is same as the UI, but with an addition of being able to specify a prefix used for a cache key. By using the Invalidate Cache policy, which allows you to build a fully customized API resource to invalidate specific entries. For more information on this topic, refer to the documentation, and if you have any questions, please post them on the community. Thank you.